Welcome back to Programming Logic and Design. In this section, we're going to be discussing remaining within array bounds. Every array has a finite size. We know that a number of elements is in an array and a number of bytes is in the array. Now, the arrays are composed of elements of the same data type, and it's those elements of the same data type that occupy the same number of bytes in memory. Now, if you recall in previous section, is that the number of bytes in an array is always a multiple of the number of array elements. So when I talk about the multiple of the number of array elements, I'm talking about, we have an integer, for instance. An integer stores 4 bytes in our memory. So therefore we're going to have 4 by 4, which is 16 bytes. So here we'll have for position at subscript 0 of our A array is going to have 4 bytes. At subscript 1 for array A is going to be 4, 4, 4 for subscript 2, 3. So therefore it will be 16 bytes in total for our int A array with size 4. So we also access data using the subscript containing a value that accesses memory occupied by the array. So we're going to be accessing the data for A subscript 0 using its position by using its subscript as its identity or its name of where that array is placed in memory. Now, we know that program logic assumes every number entered by the user is actually valid. Now, when an invalid subscript is used, some languages stop execution and issue an error. Other languages access a memory location outside of the array. An invalid array subscript is a logical error. And we call this out of bounds is basically when we are using a subscript that is not within the acceptable range of our array. So the program should prevent bounds errors. If you recall this example, when we had discounts and we wanted to enter in 100 as our quantity, 100 would have been out of bounds because we've only got 76 elements within our discounts array. So therefore 100 will definitely be out of bounds for discounts. So if the number entered by the user is too small or too large, the subscript is out of bounds. So what's going to happen if the user enters a too small or too large? Now, if we have a look at this example, the user is going to enter a value that is too large. In other words, let's have a look how memory addresses for our array works. So at prices sub 0, we've got $25, and his memory address is 4 multiplied by 0, so multiplication first, plus 4,000, which is going to give us a memory address of 4,000. For prices sub 1, it's going to be 1 times 4 is 4, plus 4,000 is 4,004. And for subscript 2, it's going to be 2 multiplied by 4. Remember, 4 is our num, which is our data type, which is our bytes in memory. And that is going to be 2 times 4 is 8, and 8 plus 4,000 is 4,008. Now, if we ask the user, or if the user has mistakenly said, all right, I've got prices for subscript 3, we're going to point to an address of 4,012, which is out of bounds. In other words, it's not within this array. It's exceeded, or it's too large for the elements that have been initialized in our array. Now, different programming languages report this error differently. Now, in addition to subscript out of bounds is one error which the programming language might give, or subscript out of range, you may also see messages such as invalid index. Now, the array processing is prone to off by 1 errors because loops are used with 0 relative subscripts as well. The program can check the validity of the data before using the user's input to index the array. Let's recall this program. All right, we've got string, our months, and remember our months are starting from 0 to our last month, which is 11. Now, what the program is doing here is that he's going month num minus 1. So he's making sure that we are actually including the correct month, because what's happening is that the user is inputting the month number. So let's say he wants January and he inputs 1, because logically we know the first month is 01. So he's going 01. You got to go, okay, if it's 01, then it's got to be 1 minus 1, which is going to be, the month is going to be actually 0, my position 0, which will be month 0, which will be January, and that's what we output. Some programmers rather have a 13 element array. So what they're going to do is their array here will be 13. And the first element in the array here will just be, so an empty string here. So when the user actually inputs 1, it will automatically, so we don't actually need to write code this section, it will just automatically output January if we are looking for January. I have a problem with this because we are creating unneeded space here in memory. It's a waste of memory location. All right, so I'm going to the original coding, which is 0. He inputs 1. We go 1 minus 1, which is 0, and we're going to output our month at position 0, which is, of course, January, will be outputted. What is going to happen if the user inputs a number that is too small? So in other words, he inputs, let's say, mistakenly, he inputs -1. What is going to happen? So he's inputting -1. We're going to go -1, which is now -2. It's a negative number. What is my program going to do? Well, it's going to do two things, depending on the programming language, of course. It will either stop execution of the program and issue an error message, or that error message will not even occur. And what's going to happen is that it's going to access some value in memory location that is outside of the area occupied by the array, and that area might contain garbage, or even worse, it accidentally might contain the name of an incorrect month. Either way, a logical error occurs. Now, how would you fix this program? Well, there's a couple of ways you could do it. You could display an error message at the end of the program if they input the incorrect data. You can use a default value for the month. For example, when an entered month is invalid, you might want to just assume that it might be December. Or you can continuously reprompt the user for a new value until it is actually valid. The way you handle an invalid month depends on the requirements of your program, of course, as spelled out by your user, your supervisor, or simply your company policy. Please join me in the next video in which I'll be discussing using a for loop to process arrays.